Right, yeah, so we're going to talk about modern Java in action. Now, what I'm not going to do, and I'm going to just say that at the very beginning, I'm not going to really introduce this feature in a slow and formal way that helps you to learn them if you do not know them already. That means you either have heard about this feature somewhat and are ready to see what they look like, or you're totally okay with being bamboozled by something that you've never seen before. If you're not in either of those two categories, if you came here to let me slowly walk you through how these features work, then this is not the right talk for you. You're invited to stay here, but I just want to manage expectations. Right, so let's get started. What we're going to do is we'll implement a little GitHub crawler that connects to GitHub, tries to figure out what kind of page it's seeing, and if it's a GitHub page, it tries to find the important part of the page, find more links, and put the links back at the top, and then keep going. We'll aggressively use, abuse, and arguably overuse modern Java features. So not everything I'm doing, you should be doing the same way. I just want to see what it could look like, and then you make up your own mind of how far you want to push it. As I already said, this is a showcase, not a tutorial. And I do make videos on YouTube, but most of them land on the Java YouTube channel. So go to youtube.com/Java, with or without the ad, doesn't make a difference. And there you'll see the Inside Java newscast that I make every other week, but also lots of videos from my colleagues, short form, long form. There's tons of details there on everything that I present today. If you want to have a look at the code base, go to github.com/nipafx/modern-java-demo and read the README. It's super short. But without the reading the README, you will have no idea what you could possibly do with that repo. Okay, and you can ask questions at any time. It is a fairly big room, but I think I'll be ready. But you can also put them into the app. And let me tell you now, in case I forget, we might run out of time towards the end, because it's live coding, you know. If I'm not ready to take your questions up here, you can ask me after the talk. You can ask me throughout the rest of the conference. I'll be here at least until tomorrow noon, probably a little later. I leave for Utrecht in the late afternoon. But I'll probably be here until like, I don't know, 2 or 3, so you can ask me here. Okay, so let's start crawling GitHub. I already kind of explained this to you, but let's go over it again. We connect to a URL. We identify what kind of page is this. Is it a GitHub page? Could be an external page, right? Maybe somebody linked to Wikipedia. Could be a 404. We identify the interesting section, not the header, not the footer, just the conversation on a pull request maybe. And then we look for outgoing links. And then we take those links and we go back to step 1, plus we count the depth, so at some point we stop, so we don't actually like crawl literally all of GitHub. And then we will do a few things with that. We can print some statistics, we can print a page list, and we can show the pages on localhost. And the interesting thing about this is that these operations are super simple, but they're stand-ins for more complex operations. And we're going to use a certain kind of design that separates the operations from the data. So the game plan here is for the domain model to use records and sealed interfaces to model closely what we observe in reality. To fetch the pages, we're going to use the HTTP client that was added to Java in JDK 11, and we're going to use virtual threads via structured concurrency to get both great scalability, which is entirely pointless for a hobby project like this, but, you know, I still want to show you, and also good insights during debugging. I'll show you later what I mean by that. We'll present the results with text blocks, and string templates used to be part of the demo. They're not anymore because the string template preview was removed from JDK 23. If you have played with the string template preview in JDK 21 and 22, in 23 it's gone. If you have questions about the reasons for that, that's a great topic to discuss later. And we're also going to host the result with a simple file server that's added to Java. So that one was added for experimentation, for stuff like this, for testing. And of course, we're going to use modules, because modules are good, right? Okay, so let's go. And let's start with some code. Okay, so this is the code base that I have, super small, contains basically nothing at this point. Let's start with the domain model. So we're going to start with, let's start with external page as an example. And we're going to make that a record. What can an external page have? Well, it has a URL, right? So that's something we need. And then what else? It's a page, so probably has some content, right? The content that we wanted to identify. So let's go with string content. And that's our record, right? We could stop here, but very often there's additional things you want to do in record. One common thing you want to do is you want to verify the data. I'm going to use a compact constructor here. That's a feature that records have, where I do not have to assign to fields. I do not have to repeat the attribute list, the parameter list. I can just do things. And what I want to do is, I want to make sure that object It's not that easy actually to type from here after all. There we go. Require non-null. For example, I want to make sure that the URL is non-null, right? You really want to make sure that with these records, specifically that the data is correct. By the time you have an instantiate a record, it must absolutely be correct. So let's also require that the content is not null. And then there's additional checks. For example, we could say that the content should not be blank. If it's blank, we can throw a new illegal argument exception, for example, right? And then we put something clever here. Okay, so records, super small to define, but if you want to do something, if you want to use them throughout your system, you probably want to add additional checks, like this one, the constructor. Another thing that we could do is we could customize hashcode and equals. We don't have to. We get a hashcode and equals that builds on the URL and on the content. That's good. But presumably the U in the URL stands for unique, right? If I remember, universal, something like that. So it should be kind of only one, right? So let's try that. Let's have an equals and hashcode implementation that only uses the URL. And let's create one with IntelliJ. But now we're going to do a little trick. Mainly, we're going to implement this in a cool new way. We're going to use patterns. So let's say we return. Well, we can do the this equals O trick. It's not always necessary, really, but it's okay. Let's do this. Okay, so either this is the other one, or if it's not the other one, well, what we do, we want to make sure that O is an instance of page, right? Sorry, external page. And now we use a type pattern. We call this ext or other or something like that, right? And that means if the check is true, we can actually use the variable ext here. And then we can say, for example, ext.url equals, and there's no there's no null here, right? So we can be sure that this won't NPE on us. Okay, so what I've used here is pattern matching, specifically type patterns. We're going to see so much more of that in the future. I mean, later in this talk is what I mean. Okay, so let's create one other type. Let's create a GitHub issue type, maybe. GitHub or PR page, that's the type. Let's have another record for that. That starts with the same kind of things. We have the URL here as well. We have some content. And what we also want to have is a set of links, of those outgoing links. And for now, I'm going to call, you also use URI here for these outgoing links. And then we have a PR number. And we can have the equals and hashcode implementation, and we can have a custom compact constructor here as well. Specifically in this compact constructor, after you've done the checks as in the other class, what you probably want to do for, checks as before, sorry. What you probably want to do in a record constructor is you want to make sure that the parameters you're being handed, that those are immutable if possible. URL is immutable, content is immutable, the integer PR number is immutable, but the set is not. Somebody could give me a hash set, hold on a reference to that set, and then change it. Or worse, they give me the hash set, and I hand it out via the links as an accessor, and somebody calls clear on that. So that would be terrible, so I want to make sure that it's that we have immutable copies here, and for collections, that has become super easy. You go set copy off in this instance, and you just make a copy of the links. So I'll just reassign this argument. As I said earlier, at the end of this block, we'll get all this assigned to the fields. If you do this, map, set, list, they have all these copy off methods in Java 10. Since Java 9, you have set.off, list.off, which is a great way to create a small immutable list or set or whatever when you already know all the values, right? You know that for this test case, this list has these 3 entries. You just go list.off and write them down. You've probably used that before if you're in a recent Java version. And what we could also do, by the way, records can add methods, you can implement interfaces. Let's have another constructor, because I already know that later, I have a constructor where I do not have a set of links yet. The set of links is empty. So you can create additional constructors here that, just like with regular class constructors, have different parameter lists. In this case, we just pass it on to the actual canonical constructor, and here IntelliJ nowadays is clever enough to do set.off. Just a couple releases ago, they still put in a new array list here, which is mutable by default. This, I think, is much better. It's immutable by default. And that was it. We could keep going like this, but there's like 2 more types to create, so I'm not gonna. So instead, I'm gonna do git eradicate, which is my personal command to throw everything away I just did. And then we're gonna check out the commit that does it properly, just in case I made any mistakes. So we want to make sure that we got the right types here. So you can see now there's 2 more types. We have error page, in case, as I said earlier, we have 404 or something, right? That can always happen. We have an external page. if somebody linked to GitHub, and then we have the issue in the pull request page. And for now, we're going to pretend that GitHub has no other pages, right? Just for now. Now, we could say we just modeled the entire thing, right? Those are the 4 kinds of pages we're interested in, and we modeled them, so we're done. But there's an additional relationship here that we've not yet expressed, and that additional relationship is, well, all of these are a page, right? They seem to have like some type in common. It's actually even at the end of all of their names, so it feels like there should be maybe a page interface. But then if I have a page, I can also already tell you that there are only certain combinations allowed. I either have an error page because the connection was not successful, or I do have a successful connection. And we can start expressing this with sealed interfaces. So let's create a sealed interface page. We're going to make it sealed, which means not everybody can implement it. Only these types can extend or implement. So you can list both classes, records, or interfaces here. So successful page or error page. There we go. So only these 2 interfaces will be able to be pages, and all pages, I think we have established by now, do have a link. There we go. Okay. Sorry, do have URL. Okay, so now a successful page doesn't exist. Let's do that. Let's create a successful page. We're also going to make this sealed, because each successful page, where does permits go? Maybe here? I think here. Either successful, a page is, if it's successful, either connected to an external page or connected to a GitHub page, right? There are no other pages. That's how we built this, this domain language, or external page. Yeah. By the way, excuse the typing. It's always this bad, but it doesn't help that the monitor is over there. But it's like in generally, I type terribly. So I hope you can forgive me. Okay. Let's go with the GitHub page. Okay, and if we're on GitHub, again, we're going to pretend that there are only the 2 types exist that we just created, which is GitHub pull request page, and then the GitHub issue page. Oh. There we go. Okay, I kind of forgot that all successful pages have content. We never need these accessors, but might as well write them down while we're at it. And this is interesting. They all have a set of something that we call links. A set of what? Well, earlier I made it a set of URIs because I didn't have a type for all pages. Now I do. So now we can make this a set of page, right? Okay. Now these types don't implement that yet, so we have to make it implement them, and then this does not quite line up. So these are records, right? And each record component has its own accessor. So for the string content, you get an accessor, string, content, opening and closing parenthesis, which, not entirely coincidental, is exactly what I wrote here, right? So this lines up. This method that I described in the interface, which is indirectly implemented by this class, lines up with this record component. Now this one does not line up though, because I said that the links would be page, set of page, and not set of URI. So I have to quickly fix this here. And then in the other one as well, we make it implement that interface. And then we make this a page. And I think we're slowly getting, oh, no, there was another error there, to an error-free stage. There we go, this implements page now. Okay, there is one more thing that we can implement on the GitHub page type, but I'm not going to implement it because it takes a while. GitHub page, let's just copy paste it. So that would be this method. This is a default method, meaning it comes for free and every interface implementation has it. They can all overrule it if they want to, but if they don't want to override it, we'll keep it. The interesting thing about this is what it does, it streams through the subtree, right? So if you have a page that links to other pages, which links to other pages, they are backlinks, so it's not technically a tree, but we can ignore this. It kind of still works. We can stream through the subtree, right? You can say, starting here, I want to get a stream of all of those nodes down there, of all those pages down there. And that's what this one does. It's not that terribly important how exactly it works. I just want to point out 2 different things for you, and that is, there it is. Okay, that's this remove first. I'm calling this on a collection, on a list, I think, and then this reverse call here. So the interesting thing about these 2 methods, remove first and reverse, is that you might not know them. They're new sequence collections added them. That's an addition to the collection API that made sure that those collections that do have an encounter sequence, like lists, like certain kind of sets and certain kind of maps, actually have this enshrined in a type, and then you can do stuff like remove first or add last, or you can just reverse, and then you can stream over it in the reversed direction. This is a small little addition to the API that is super helpful and that we're going to use later. Okay, that was it for the sealed interfaces, I think. So now we got our domain model all done. Let's do the same trick as before, and let's throw everything out and check out the correct version. Okay, good. So that's all that. Now let's have a look at our first kind of operations. So if you have sealed interfaces and records like this, then there are certain kinds of methods that are fine to put on the page, right? If the page just needs a nice name, then already has all the information it has, it can just rearrange, the record can just rearrange its own information and present it to you as a string. But there are certain operations that seem to not so much just reorganize data, they seem to take the page and do something with it, right? So let's say we want to do mood analysis. Yes, it's based on the content in the pull request exchange, right? But if we do mood analysis, clearly we're reading that data, putting it into a larger system, and that larger system needs to process it. So the idea here is that those complex operations should not be part of the API of the record. The record should not have an analyze mood method, because that means it needs to know a whole large subsystem that does some kind of language, you know, inference and whatever. We don't want that. So I want an external system to get a page and then take it apart and see what it can do with it. And because I'm not going to write a mood analysis tool for you here, because I can't, but also it will take too long, I'm instead going to do the pretty printing, right? So the idea here is that we want to implement these two methods. And the bottom one is the one where really the magic happens. We get a page. We don't know what kind of page. We just know it's a page. And now we want to turn it into a string that looks nice. Now the problem is, if you look at page, you realize we have basically no information to work with. You'd think. But this is also important information, and we can definitely work with this. So we know that page is not just any random type. We know there's only two subtypes, you know, and some of them split up further. So what we can do here is we can switch over that type. We can say, okay, let's return, and then we switch over the page. And now what cases could we have? Well, it could be an error page, right? If it's an error page, we're gonna return as a string, maybe we write error, and then we go with, the error has an exception, right? There it is, and that would have a get message. I don't know, maybe this. Okay, so two things. First of all, you see that there's a compile error. That's great. The compiler is telling us that we're not yet covered all kinds of pages. There could be more kinds of pages. I mean, we know there are, right? There's not just error pages. There's also other kinds of pages. So there's three more cases we probably want to handle. And the other one is just overall the syntax here. So we say return the result of the switch in case it's this error type. Then we go to the right-hand side, and then we can use the variable error on the right-hand side. We can go a step further if we want to. We can already take the error page apart. We're using a different kind of pattern now, deconstruction patterns. We're saying, look, the error page, I know what the error page is. It's a URL and an exception. Let's just take the exception. I don't care about the URL. So okay, let's ignore the URL, and let's take the exception. And then here, we don't have a variable r anymore, or here, but we have an exception now. And we can keep going like this. We can say, if we have an external page, then we could also take this apart, right? Maybe for the external page, we just care about the host and not about the content. And then we say external, and this, by the way, was where the string templates came in, but you know what happened to those. URL, get host. There we go. Okay, and I'm gonna spare you details of getting going now, like, well, you know what, let's do one more, and then we copy paste it, and then we have it all here. GitHub issue page, for example, and we're also gonna take that apart. And now I know by heart, the first one is the URL, the next one is the content, the next one is the children. I only care about the issue number. Yeah, let's just go with issue. Okay. And that's, oh wait, you know what? Actually, it's easier for me to look there because there is no glare on the display there. Okay, let's go with issue. And then we do the same with pull request number. And then when we do this, the compile error page still is red underlined. That one will go away once we fix this last, thingy here. I'm gonna call this one PR, and then this one is PR. There we go. Oh, I've got the type here. Okay, so hope you can all see that well. And now the compiler's happy, right? Oh, well, there's a semicolon missing at the end. And that's really cool, because this also means that switching over type might seem dirty. Well, I shouldn't do that, right? Like, that's like instance off. But there's a difference between this and a series of instance off checks. If we add a fifth type, let's say we find out that commit pages also exist, and we put GitHub page permits GitHub commit page into that sealed interface, then the compiler understands that this is no longer exhaustive and will give you compile error. And that makes this safe. It makes it as safe as if you have an interface and one of the implementations is missing a method. It makes it as safe as the visitor pattern. It's just as maintainable, but it's arguably more readable than the visitor pattern. Okay, we've not done this up here. We can do a little trick here. So basically what we want to do is we get the root page here, and what we want to call is we want to write root page, and then iterate through all the children, but we can't go through all children because the root page doesn't have that, right? So again, we have to, it's fine to check on types here. We know that only if the root page is an instance of a GitHub page, that's the one that has the subtree, then we can say take the GitHub page, take the subtree, and that is already a stream, so now we can map with and then page name, and then we probably join this, right, with new line maybe? Sure, let's join with new line. So each page is its own line, and otherwise, I'm just gonna return just the name of that. Just the name of the root page. Again, so we're doing a type check here, and that's fine. Like it's not only with it's with instance off and the type pattern up there. It's more elegant, but the more important part is it is fine to handle types like this if the kinds of implementations that you can expect are part of the type definition, which they are, right? Like this page, this tells you what other types there are. This is not random. It's not like if you switch over if you make an instance of, is this list an array list? Is it a linked list? Because there you have no idea how many other implementations are running around. But here you do. We do know exactly which implementations are around. So this kind of code is fine. Okay, we could go into the other operation, the statistician, and do a little bit more there, but that's not really necessary. I think it's fine if we just instead, there we go, run the code for the first time. So what I did here is, this is the main method, by the way, it just creates a few instances by heart and then just runs something, right? So this is not really doing anything, it's not connecting to anything yet, it basically just prints what's up there. And let's see whether that worked. So we get down here, yeah, we got a few lists. Hope everybody can read that. Is that fine? It's too low, right? There's not much I can do except maybe pull this up a bit. Okay, let's see. Right, so this is the pretty printing, right? So it's not amazing, but it does its job. So you can see it's already working. Because now we're gonna add the actual implementations. So let's go here, let's check that out. And now we will see a ton of errors here. So there's a bunch of things wrong. Okay, so let's start working on these. The first one is, I want to go in here in the page, I think page 3 factory. One of them needs like a little record. Oh, there it is. It needs page with links. So far I created a record as kind of like the domain objects that I really want to work with. I took them very seriously. They were important for me. They were in their own package. They were all public. And that's all good. But you can also use records much more ad hoc, like this one, for example. This record, I don't even need to be public. It's only visible in this package. That's the only place where I need it. And it's gonna have, all right, I use this while I'm still collecting the URLs for a page. So I already have most of the page, but what I don't have is the URLs yet. So here I actually do need a set of URI, and it's even funnier, I do want this to be mutable. Like intentionally, I want to make sure that I can mutate this, right? So I said earlier with records you want to lean on immutability, and that's right, but that's correct, but you can make reasoned exceptions. It's fine not to do that. So okay, let's make sure that this works. So let's create the compact constructor that just creates, this time we do it the other way around, it says create a new hash set. Just whatever it was before, now it's a mutable hash set, so that's nice. And then down here I already know that I need a constructor that does not accept the links because I don't have one yet. So here I go with the page, and then, I don't know, I can do set off because I'm making a copy of it anyway. It's a little bit wasteful, right? Like I'm creating an empty set here, and then I'm creating another empty set from that. Doesn't matter. Okay, good. So that was like the first quick fix, right? So what I'm trying to tell you here is it's perfectly fine to treat records either as essential domain objects that you really put a lot of care in, but these ad hoc types, they work really great for as well. Okay, now let's go up here. We got a few compile errors. I got a compile error here for org.jsoup. Now that's a bit weird because if we look into the source tree, it's a dependency. It's down here. Why could this be red? What could be what's the problem here? Anybody have an idea? I can see you all not using the module system. You're not using Java modules. I told you you should. Look, then you could have answered this. So the reason here is, yes, the dependency is there, but our module declaration does not actually express that we're depending on it. So this module info Java here says, oh no, I don't have any dependencies. IntelliJ already knows that, no, you do. Okay, so let's go there and let's fix this. Let's add this requires here. So now, great, we're now depending on org.jsoup, so that's fine. And the other one, the page factory, had a similar problem because there we're depending. Oh, it doesn't? I'm somewhat surprised. Well, we'll see. Let's see. Maybe. Oh, yeah, there we go. No, I knew there was another compiler error here. This one is for another module that contains the HTTP client. Okay, so now we have officially written down that we have these two dependencies, which is good. It helps us understand what this module does. By the way, if you want to have project-wide documentation, this is a great place to document that. If this dependency is supposed to be deprecated because you want to remove it, this is a great place to write this down. If this requires a little bit odd and maybe your future self or your colleagues wouldn't understand why we need this, you can put a comment here. This is a great place to document on a high level what that module is doing, but also anything else about its dependencies, or else you can, like, this is a great place because it will show up in the Java doc of this project. Okay, let's deal with this HTTP client. So let's start there. We want to make requests, right? And the GitHub Crawler actually is supposed to instantiate the HTTP client, but we don't have one yet. Here it's null. Okay, so that's bad. Let's fix this. This HTTP client API is reminiscent of, for example, OKHTTP and other such libraries. So no longer you have to have like URL, open connection, all that stuff. It's for good reason. It's all gone. So let's create a new client. The client can, once it's built, can be used on as many threads as you want. It's thread safe, and we just build it. So the idea is to build it once with the configuration that you need for a certain service or for all of your services, and then reuse the same client. Okay, so let's create a new builder, and now we can configure whatever we want. Like you can authenticator, connection timeouts, cookie handling, redirects. You can put all of that here. We need none of that, so we're just going to build. And now we have the client, and now we're going to go to the page factory, maybe, nope, page tree factory, which at the bottom here, this is what we need to implement. So we have a URL, and what we need to return is a string. So what we really want to do is, we want to basically say, okay, we got the client, we want to send a request, and then we're gonna want to get the body of the request, right? That's what we want to do. Okay, so let's go there. Let's start with creating the request. The request also is once it's built, is immutable. So you can also do the same trick, right? If you know you have to ask the same request with the same kind of parameters a lot, you can just prepare that in one place and just inject it, for example. Okay, so let's go here, let's create a new builder, and then you will see that you can overwrite a lot of the things that we could have configured for the client. You can overwrite them locally if that's necessary. What we definitely need to do here is we want to get, and I'm pretty sure I don't need to write all of these down. I think get is the default, but just I like to read it out, so let's put it there. So now we got the request, and now we can send the request and get the body, almost. This API is understanding that sometimes a response or request could be way too large to just handle as once. So you have this point where you can intercept how the return body gets handled. You could do something smart that does like line-based reading and emits events. Like you can do lots of things here, but we're not gonna. We're just gonna say, okay, we want to turn all of this into a single string. And that's why the thing we get back then is of the type HTTP response of string, right? So the body handler of T and the HTTP response of T, that's the same T because we gave it a body handler that wants to return to string. We get an HTTP response of string, and then .body returns a string, and that's all great. Okay, now let's use this This is using a blocking call, right? You might notice that I'm calling send here, I'm throwing an interrupted exception, and I mean send should tell us, I mean it's a HTTP request, right? It's probably not going to come back immediately. And then also the interrupted exception really is the marker here that says this will block and wait. And now, if you do like reactive APIs, that's fine. There is a send async here that you can use then complete with future and all of that to handle that. But specifically Java 21 and later, you don't have to anymore. We have virtual threads now. So this blocks a thread, which again, in this project doesn't matter, right? But if you imagine you have like hundreds of requests at the same time to different servers ideally, because hundreds of requests to the same server might get you in trouble at some point. Then you don't want to block hundreds or maybe even thousands of operating system threads. So you want to use virtual threads. So what we kind of want to do here is so down here, the task is, given a bunch of links, we want to call the method that turns each link into a page. So there is a method that takes a link and returns a page, and we want to call that. Which one is it? I think it's somewhere in here. Let me figure it out. Might actually be this one, create page. Yeah, create page, that's the one. So what we really want to do is down here, we basically want to say, okay, given all these links, we want to stream over the links, and then we want to map each link to create page for that link, and then we have to pass on the depth. Somewhere there's a step that does depth -1, but it's not here. And then that's basically what we want to do, right? And then we probably want to turn this, I don't know, into a list or something. Now this doesn't work because create page throws an exception and the compiler is not happy that we're not handling it. That's one issue. But the other issue is if we would do this, we would still send like one blocking request after another potentially, so that's not great, right? This is no parallel stream, so every execution of the Lambda will be its own execution on the same thread. Every time it blocks, that sounds terrible. So let's use virtual threads, and let's not just use them anyway, let's use them in a very specific way, and that's called structured concurrency. So we're going to create a task scope, new structured task scope, and we're going to create the kind of task scope that shuts down on a failure. So if one of the tasks we submit shuts down, then all the tasks will be shut down. Okay, and now we kind of do this, but not quite. So for every task, we go to the scope and say, please fork yourself, which sounds kind of rude, but okay. And then let's do this. Okay, so now we're saying, for each link, fork a new task from this scope and execute this task in there. And the structured task scope will use virtual threads for each of those executions. Now we're going to collect all of that. We can call this, I don't know, pages or future pages or page tasks. Maybe it's a good one because it's, as you will see now, it's a, oh well. Oh, you can see down there. It's a stream of subtask, whatever subtask is. It's a fancy supplier in the end. Okay, once you've fired all of this off, this happens immediately, right? It immediately starts all these virtual threads and fires them off, and they get busy now, and they might take a while to come back. So we need to wait, and we wait by going to the scope and saying, let's join. And then once we joined, let's throw a failed, because something might have gone wrong, right? Let's add this to the execution. And here, I mean, like in this specific situation, I can say, wait a moment, that should have been handled by error page, because we have this type specifically, so whenever page creation breaks, it should have created an error page instead and returned that one. So this really should never happen, but you know, it might. Okay, once we're done with that, now we're ready to get the results. So let's get the page tasks. And once again, we just stream over it. And then we map for each subtask. We say, get me the result of that subtask. Remember, this get call is now instantaneous, right? We waited for everything to continue. Sorry, to be done. So this call is instantaneous. And then we turn this into a set. And return it. And there we go. And that's structured concurrency. Now let me see whether there's more to do before I can run this. I don't think there is. I think this should be fine. So let's now, if I didn't make any mistakes, which is kind of likely that I did, but we'll see. This should work. This method changed, so now it's actually going to GitHub. It needs a seed URL, but I already configured that in the launcher when I prepared this project. Okay. Oh, yeah. Oh, you folks already knew this, right? You were just waiting for me to come back here. Okay, let's try this again. That looked like an error down there. Oh no. Let me quickly go into the Wi-Fi. I knew there was something I wanted to do. So what's the GOTO Amsterdam password? It's on my badge. GOTO Amst, like I just write it out? All lowercase. 2024. Okay. I'm terribly sorry. That I should have done that before. I thought I did actually earlier. Okay, let's try again. Sooner or later, it's supposed to work. Okay, better. It's trying to resolve stuff. You occasionally see found cached. That's because there's links back and forth. I was smart enough to only fetch each page once. And that's the result. So it did something. That's kind of cool. Look, I smuggled in the emojis, so it looks a little bit nicer. But there's something specific I want to show you related to virtual threads. And for that, we need a breakpoint, because otherwise I cannot, I'm too slow to make this work. We need the breakpoint somewhere where we create the GitHub issue page, I think it is. Yep, there. And we just needed to stop it for one of those. And I think I do 740 is, I think, the one that I want to use here. So if, oh, wait, what? If issue number is 740, then we'll stop here. Okay, let's run again. Okay, that's good. And I smuggled in a log message here that helps me with this, which says, to see virtual threads in action, run this command while the app is resolving a bunch of links. Okay, let's try this. Let's take this from here. Let's put it onto the terminal. If I fire off this command, it will block because the app is currently in a breakpoint, so it cannot actually run. So let's remove the breakpoint and keep running. And now let's hope this worked. And it didn't. I just said open socket target process. I think that was too slow, maybe. Okay, let's try this again without the narration. Ah, damn it, breakpoint. Okay. Hey. Maybe now? Hey, that looked better. Okay, so we just did a thread dump. If you are having issues with your running applications, that's not the first thing you want to do. Probably you're hoping for log messages, you're hoping for stack traces, all of that good stuff. If none of that works, you might have to look here. So this is something that you will see in there. For example, this is just a stack trace, right? So something is waiting in sunmisk unsafe, apparently. If we go through this, we will see why they're waiting occasionally. For some of them, you will see that these are all in a thread pool. But for some of them, we will sooner or later see that this one, I think, is looking, or the log. There we go. Here we're polling some ports. So, things are happening. The interesting thing is that with virtual threads, the way we did it, if we look at the code again for the GitHub, for the page tree factory, if we look at this code, here is where we start virtual threads. Here is where we are in the breakpoint. These virtual threads were all started with this thread that was running this as its clear parent who said, okay, I'm going to pause now, you do your thing, and when you're done, I'm collecting you, and then we'll be finished at the catch block, or rather when the try catch block is done, this structured task scope is shut down. So the interesting thing is, usually you have threads that exist independent of one another and occasionally give each other work, right? You have a worker pool somewhere that gets work, and it does this work for now, but later it does somebody else's work. So these threads are independent. But these ones are not. The virtual threads are specifically spawned as children of the thread that does this work. And you can see this here. Because for some of them, actually for most of them, because most of them are virtual threads, we'll see there's an owner. And for some of them, it's even non-null, actually. At least it's supposed to. Wait, what? Oh, well, right. There we go, right, Jason? Okay, good. So this one has owner number one as thread number one as an owner. And the other ones have different owners, 35, 93, 148. That means if you do a thread dump and you're stuck here and you want to understand what's going on here, I don't understand, I need more context. The same will be true once IDEs debug this. You go through a stack trace and you realize, why is this happening? And then you end at the top of that thread and you've lost. Because how do you know which other threads pass the task on? What's their context? And with this, you can switch, right? So you can go all the way up in this stack trace, and then you realize, okay, the information that I need is not here. But you know where else to look. You can now go look for the thread number 38, and you will see what it is doing right now. And if you would do this in your IDE, you could see what its stack variables are right now, and its stack trace, and you can go on. So if you use virtual threads all the way down, from any minor breakpoint anywhere in your application, all the way up to the main thread that collected this from an open socket, all of those are available to you. So you can see the full context for debugging, and I think this will be amazing. I think this will be, I would say it's as important as being able to click on a stack frame, but not quite, because you can mostly fix your problems by just navigating around the stack. This is not that often necessary, but if it is, it's extremely cool that you can now do this. So I'm really happy for that. So that was virtual threads and structured task scope. Let's go back. And now this would be the part where we would usually do the string templates. But as I said before, that's not happening right now. So we're going to ignore that. But I can tell you a few things that would be happening here. Let's close all this down. So I got a new folder here, which is called surf, which contains some CSS. And the idea here is that we're printing the thing we just did as HTML, and we want to launch it. We just want to have like a simple little web server that we can launch. Now, this is not a web server that you use in production. It's for testing, it's for experimentation, it's for that kind of thing. But it can be really handy. So let's go here into operations. We have a new one now, which we call result, which is called result server. And it does the HTML right here. And you can see that it does JSoup and parse. You can do this in a different way as well, right? But this is where the string template would come in, but it's not, so we use string formatting. We write all of this into a file called index.html. And once we've done that, we want to start a web server here. And that's super simple now. So if you need a simple web server, then go to simple file server. Sorry, simple file server is the file called. And then we have a create file server, and that needs a new inet socket address. We're going to pick 8080. And then we're going to have to give it a path, and we're going to make it the server directory. We need to create an absolute path from this. I learned this the hard way. And now I think we need some output level info or something. OK, that's super simple. Oh, semicolon is missing, though. It's not that simple. So if you need something like this, you can see it's straightforward. We can now have all of this generated, and if we, oh, by the way, the same web server that I just launched is also running these slides. These slides are HTML, CSS, and JavaScript, and I run them with JWeb Server, which is using the same code under the hood. So now we can go to localhost 8080, and that doesn't work. Oh, I think I know what the problem is. We need to, this might, yes, it totally helps to start the web server. Always something, right? With this Java API, it's always so complicated. Unbelievable. Okay, good. So that you can see that those are the strings that we just created, plus the emojis that I was too lazy to put into code here, and then just some CSS to make it look nice. This is not prepared. This is what we just pulled from GitHub there. And as I said earlier, this is not really a tree. It has backlinks. So that is the backlink indicator. It's like, we already had this page further up, go check out there. Okay, cool. So if you need a web server, as I said earlier, the presentations also work that way. So you can just go web server. It's probably not going to work now because I used the address already. And that's just simple command that's in a Java binary that you have there now. Okay, now we do the last thing. Let's imagine I would not be using an IDE for whatever reason. Maybe I'm on a remote server and I, SSH in. Or maybe I'm a beginner and IDEs are just, too much for me. So let's close the IDE, and let's do a little tree here for the source directory. The source directory. So this is my source code, right? I mean, there's more in this project, but that's mainly it. Let's do a quick Maven, which unfortunately I need. I'm going to explain in a second why. But it's only needed for getting a jar into the right place. So these are all source files, right? How can I run source files? I have to compile them, then I have to run them. I have to make sure that they end up as a jar. No, none of that. With Java, I can just say, okay, and actually the code completion is terrible though, so let's start with this command, source, main, Java, and what's next, def, and here somewhere is the GitHub Crawler. Okay, good. Let's launch with the Java. Okay, so I want you to notice something. I threw this at the Java executable, not Java C, and it did something. It was like, wait, this is a source file? Oh yeah, I can compile that in memory, and I can just start it. But it can't just start it because there's a module missing, which is kind of weird because it means that while I told it to launch GitHub crawl, which is in demo modern, whatever's above there, it found this file and looked it up. So it did find the other files, and it noticed that something is missing. So that's why I had to run the Java command, the Maven command earlier, because I have this directory here which contains my only dependency. So let's put this onto the path. And it's still not going to work because I use preview features, so we have to also enable preview. Okay, and still not going to work because I still have to pass command line flags, but that's my bad because I built a complicated API, so I have to give a URL here. Okay, but now it works. So what we're doing here is, we just write source files, and we just launch them from the terminal. I mean, clearly, writing this kind of code outside of an IDE is entirely possible, don't get me wrong, but I would prefer within an IDE, but for smaller projects, right? Like you're just experimenting. You can cut all the IDE, all the install, you only need a JDK and a text editor, and then you can just go. Also, you need a way to get jars, which hopefully somebody's working on that. Okay, good, so that's all I wanted to show you. So let's do a little review. First of all, let's talk about what Java version that was. That was not 21, that was Java 23 early access builds with preview features. But almost everything I showed you is in 21. These are the only exceptions. That you can launch multiple source files, as I just did, was final in 22. The unnamed patterns, the underscore that I did, that was final in 22, but is unchanged from 21. So if you're in 21, you could be enabling previews, but make sure to only use that one feature. Because if you enable previews, you might accidentally also use other preview features that might go away. And then you have structured task scope there, which is still in preview in JDK 23. We used sealed interfaces for the domain model, where we said, okay, we know page is either one of these, so we expressed that in the type system. We created all the records that we needed based on that, and we created this kind of type hierarchy, where the orange parts are records and the blue are sealed interfaces. The important part here is, this is complete. If I show you interface hierarchy or type hierarchy of the collection framework, it's always incomplete. Everybody can create a new list implementation. This is not possible here. Adding a new page implementation requires to change the page type, and then this grows. For operations, we leaned on that and did the switch. We switched over these types, and because the compiler understands that if I list all of those 4 records, I list all possible implementations of page, it's happy with me here, and if I would add a 5th, I would get a compiler error as desired. We used the HTTP client, which is super straightforward. We use structured concurrency, which might not be super straightforward, but it's still really cool. I recommend to reach up on that. A big upside of this is that this is the method create page here that actually does the work, right? So that's the method that really has the domain logic. And this method has all that stupid threading that you have to do around that. So it clearly separates the domain concern from the technical concern, and this is where this entire concurrency happens. That's why it's called structured concurrency. You look at this scope, and it's all there. It's not like you launch the threads here, and then maybe later you connect to reset and you don't know how. No, this is all there is about it. We used a simple file server that was really cool. We used source code programs like this, plus a few command line flags that I needed. And I promised you JPackage, but I cannot use JPackage because it doesn't work for my Linux distribution. But what you can do with JPackage is you can create operating system specific installers. So Jose did this in a video. So you create an exe file because he's on Windows, the PERSAP. Look here, he's running the installer. He looks super happy and engaged. There you go. You get this dialog for free from Windows, I guess. And then you have to click the finish button. And he did more. He did file associations, for example. So you can say if it's you have association properties, and then that file is over here, and that file says, if it's of the type JPEG and it's a .duke file, then open my application with it. And there you go. So if you still occasionally write desktop apps, again, even if not for your customer's production, but maybe for friends or for family or just for yourself, maybe as an internal tool, you can use, for example, JPackage to get an operating system specific installer. So we've seen that we have great domain modeling with record, sealed types, class, and pattern match, sealed classes and pattern matching. We have easy, structured, and scalable concurrency. We have a cool HTTP client that works. It's really easy to experiment and to package. And with that, I want to thank you very much for your attention. So if you need, again, we're going to maybe go to some questions, but if you want to have more details, go to this thing down there is the most important part. dev.java, inside.java, and specifically the YouTube channel with /java, where you will see lots of more stuff. Also, if you do want to learn more about the module system, you can do this. You can be one of like 10 people, a quarter, who buy my book now. So I would appreciate that.